Amazing. Hello, everybody, and thank you so much for joining us today. Just going to give our lovely host a little introduction here. My name is Hannah, and I'm a third year student at U of C in natural science. And with me today, I have Justice and Lily. Lily, do you want to give yourself a little introduction?
Absolutely. Thanks, Hannah. So hi, everybody. My name is Lily. I'm a graduate from SAIT. I took the journalism program, and I've been working with SFC for the past 5 months. Thanks.
Hi, everyone. My name's Justice. I'm a graduate of the University of Alberta. I majored in finance and minored in economics, and I've been with SFC for about a year and a half now. So
Amazing. Thanks so much, you guys. Just so everybody knows, we have some exciting news. We are currently going through a bit of a rebrand and will now be known as Young Canadians for Resources, or YCR for short. Just gives us a bit of a better look and descriptor of the demographic that we cover. So with that being said, our Food for Thought series is still the same format, just with a fresh face. So for those of you who are just seeing YCR for the first time, which is everybody, we are an advocacy group made by students and young professionals for students and young professionals, and we believe that Canada can have a strong future in resources, the economy, and the environment. Please connect with us on Instagram, Facebook, and LinkedIn at any time if you want to learn more about what we do. Joining us today, we are super lucky to have Michael Matthews. Michael is a professional mechanical engineer with 9 years of experience on manufacturing, mining, natural gas and liquids, water treatment, communications, and clean energy projects. While working in roles at the project and design level, Michael has completed numerous technology evaluations, starting from idea and concept on through to commercial implementation, as well as several end-to-end multi-million-dollar capital projects. He's a motivated project manager with a collaborative, flexible approach. His interpersonal skills, coupled with his technical engineering experience, are supplemental to his fit for purpose and value-add leadership style. Michael is very passionate and looks towards a cleaner industrial energy mix. His belief is that hydrogen will unlock incredible decarbonization potential, and today this will enable him to speak intelligently on the challenges of today and how Canada can transition to lower carbon solutions. So just before I hand the floor over here, please know that attendees are encouraged to ask questions throughout the presentation using the Q&A box, and we'll address all of these at the end of the session. And now I would like to hand the floor over to Michael. Thank you so much for joining us today.
Thanks so much, Hannah. My pleasure. So first of all, I really got to shorten up that intro. That's too long. Okay, I'm going to share my screen. I got a presentation for today.
we've had longer intros than that, so don't worry too much.
Oh, thank goodness. I hate talking about myself just as much as I hate about hearing about myself. So so here we go. I guess we can change the logo on the upper left now. But yeah, so I'm here today, guys, to talk a little bit about hydrogen in Canada's energy mix. We're going to focus on Canada for the most part, BC and Alberta, because that's where most of my experience has been garnered to date. And what I want to start with is that I'm not a hydrogen guy. I'm not going to sit here and tell you about how great hydrogen is and how it's going to solve all the problems we have today with our energy mix and our emissions challenges. What I am going to do is I'm going to provide a perspective backed by facts and other people's research and information. I'm a realist when it comes to the energy transition. I've spent the first 8 years of my career in the natural gas sector, and the last 2 to 3 in renewables and clean tech. So I've got a bit of both sides, and really what I advocate for and what I would love to see is Canada to prosper as a nation when it comes to energy. So if there's one thing that there's one flag I would fly, that'd be the one. Okay, quickly, this is Ensol. So I've been with Ensol now 2.5 years or so. I moved over from Solaris Management Consultants. It's a group of companies, and so what Ensol is it's the R&D, fabrication, prototyping, testing, and software development group. It is a separate entity, but what our focus is on integrating best-in-class technology in the clean tech space. So no internal combustion engines. We are looking to power things with strictly solar fuel cells and wind. And so that being said, we develop and focus on real world practical solutions. What does that mean? That means we're not going to push something and we're not going to be overly dreamy and philosophical about energy. Our focus is on things that work and really solid technology that's been proven in the field and is rugged. So 3 pillars: clean energy, communication, and data infrastructure. We believe that data acquisition and data is the key to accelerating projects, developing good projects, and really making game-changing steps towards climate change. We can't do anything without data, and a lot of our infrastructure ends up in roles like that. In some of the most rugged places in the world: Fort McMurray, Fort St. John, Whitehorse, Yukon, Alaska, and all over North America. That's enough about NSOL. If you want to hear any more about that, happy to talk about it. But I'm going to set the stage a little bit here. And so what this is a few graphs that some of you may have seen if you're following the energy transition and global climate change and global warming. And really, so from left to right, the things that we want to get from these figures to set the stage is that our global energy consumption is up in more or less all categories. We're consuming more energy from coal, from oil, from natural gas. Nuclear is fairly flat, but hydro and other renewables. One thing that's promising to see in the renewables category is that it's a little bit more exponential as opposed to linear than the other ones, but that's a good indication of the uptake globally. And then the average temperature change, obviously, it's getting warmer. We all know that. We're trying to limit to that 1.5 degrees C increase, but that is that's a challenge, right? And then a comment there on Earth ice loss. I don't know a ton of facts about that, but again, just setting the stage to say that if you haven't read about it or heard about it yet, we got to do something to limit the changes happening to our beloved planet. Oops, I'm trying to click to remove the participants thing. Here we go. Okay, more setting the stage. What the next couple of slides, 1 or 2, I won't dwell on this too long, but what are the regulations? What's the legislature? What are the policy drivers around all of this? And so Canada's committed now to 40 to 44% reduction from 2005 levels by 2030, and then a net zero accountability act that was enacted last year. And some of this information is a little bit out of date. There's even more that's come out, and more commitments are being made. Feel like daily or weekly, with respect to companies and governments committing to lower emissions. So past, present, and future. So now again, setting the stage and seeing what our options are and how hydrogen fits into it. So on the left, this is a lot of graphs, a lot of colors, but I really like this, and it paints a really good picture. Source being from the Bloomberg New Energy Futures source. And so upper left, total carbon budget for the energy sector. So basically what that's showing is what our emissions are now on the left axis, and then what they're projected to be over the coming years, and then what they're going to have to do. So sort of post, we're in 2022. So you see the dotted line, the economic transition scenario and the emissions budget. That's how much we have to reduce our emissions to get to net zero, which is quite drastic. And then on the right, staying on top, basically a figure of what portion of that emissions budget needs to be consumed or abated by technology. So from top to bottom, fuel switch, other renewables, wind, solar, nuclear, hydrogen and CCS, bioenergy, efficiency, and what sort of how much of the pie each of those this specific source is predicting will take. And so you see a large chunk for wind in blue, a large chunk for solar, nuclear, hydrogen CCS, and others playing into those effects. On the bottom now, the dials speak to total final energy on the left in 3 scenarios, and so all sorts of these management consultant types are going and doing scenarios, and so Bloomberg have deemed theirs gray, green, and red. And so what it is right now, 2019 on the left, and so the biggest chunk there, I'll know the screen might be a little bit small for some folks, but oil taking up 42% of our total final energy. And what that needs to look like in the green or red scenario, you see that 49% becomes electrified in order to meet that 2050 goal of net zero. That's a lot of energy. That's a lot of electrification. And so you can see what the challenge is that lays ahead. But what you also see here, and this is what I like to say to my electrical engineering friends, is that it's not all electrified. There's a lot of other energy vectors that are required to get us there. So in this particular scenario, this green and red scenario, 22% is consumed by hydrogen. And then there's still oil in there. It's not gone. It's never going to be gone. But there's a much smaller section of it. And then gas has a section as well, 5% in this specific scenario, and bioenergy. And then this scenario changes there for the gray scenario, where they say, you know, we didn't do so great. Coal's still around. A lot of things are still electrified. But yeah, that's their gray scenario anyways. But and then on the right, so green, gray, and red in sequence from left to right, and what the mix looks like. But this speaking specifically to electricity generation, so where the electricity comes from. So zooming in on that 49% on the left side. And that's where that's really where their scenarios differ, is in how that electricity is generated, because so much is being expected of our electricity grids, and they vary drastically. And so it paints a picture of what we as a society need to accomplish when it comes to decarbonizing our electricity grids, because that's where we charge our electric vehicles, for example. So I could go on, but I'll hold back and move on. So a little bit more about Canada. That was globally. So let's talk about Canada for a second, because so 2% share is what Canada contributes to global GHG emissions, which actually doesn't seem like a lot for how big of a country we are. However, we've already made strides in renewable energy. We have a lot of hydroelectric power. We're developing our wind and solar in the prairies, Ontario and out east. It's not sunny in British Columbia, so we can't put solar there. The dial, the pie graph there is actually intended for some interaction here. This is where I would ask the audience sort of, what do you think? This is a graph of Canada's energy sources in 2019. And I normally ask the group, what do you think the biggest contributor is? What do you think these dials are? And this may surprise some people when I do this. This is why I have this figure in here, but it's mostly petroleum, natural gas, and hydro and nuclear, which is again painting the picture of if we really do want to get to 40 to 45% reduction and a net zero by 2050, what we have to tackle, and we'll have to take a multi-pronged approach. But on the right figure here is Canada's current installed wind and solar energy capacity. That's 2021. So you can kind of see which provinces are doing what in that pure renewable energy generation. So Alberta's doing great with their wind power, with the wind farms down south, as is Ontario and Quebec. By proportion, it's actually interesting to notice that Nova Scotia has almost as much wind generated power as British Columbia. And you think about why that is. It's the shallower waters off of Nova Scotia for their offshore wind, and the deep and rugged terrain of British Columbia really inhibits that development. And also, obviously, British Columbia's solar is bad, like I said already. But yeah, just puts to it really just visualizes how things are progressing. So this is one figure. I really like this one, which is why I bring it up time and time again. Is what does it look like to go from the existing energy system to the net zero to a theoretical net zero energy system? This is a very dynamic graph, and so I'll do my best to explain. It's similar to those dials previously from Bloomberg, but slightly different. And so right now, what it looks like is that there's fossil fuel generation around the outside with biomass, and then inside, take one step in. What are those? What comes from those fossil fuel products? Coal, jet fuel, diesel, gasoline, natural gas, and the end use demand is the circle in sort of gray. Now, what that needs to change to is now that dial, that low carbon generation, sort of light green, needs to encompass much more of the end use demand and generate things like electricity and hydrogen to then use in that end use demand. And again, we see that fossil fuels are never really going to go away. We just, because they're required in many end use cases. And what we have to do is we have to focus on carbon capture and storage. There's a lot of great Canadian companies doing a lot of great work on that already. Savante Carbon Engineering, those types of folks. So again, that's a bit of perspective there. So Canada, is there a plan? Like, what are we doing? And now a little bit on hydrogen as well. And speaking to my involvement with the Canadian Hydrogen and Fuel Cell Association and Hydrogen BC, I represent NSOL on those organizations. And so this is a figure from them. It all starts with strategy and government. And in Canada, unfortunately, things move somewhat slower than others. And I haven't decided where to start talking about the Inflation Reduction Act in this presentation from the US, but we certainly need to move at a rapid pace now more than ever, not just because of the environment and of climate change, but because of competition. And so generally things start with hydrogen strategies. Governments make commitments, incentives and credits get put in place to spark that growth, to get that ball rolling, to build the momentum so that these technologies can scale. It takes time to do this. It took us 100 years to go from wood to coal, and 100 years to go from coal to oil. So it's going to be and that's globally. I'm not bashing Canada anymore, but we need to do it faster than 100 years. But there's a lot of great funding programs that are out there, and these are updating all the time. There's new ones all the time, but the Clean Fuel Standard has been a big piece of it. The Clean Fuels Fund will inject a lot of cash for large-scale projects. There's a lot of net zero funding. There's the ZEV targets, which you guys might be aware of, and the carbon tax that will be slowly increased over time. And so, yeah. So now some more about hydrogen. And this is a good figure again from this one from Hydrogen BC. And what this is other than the lobster claw is another analogy on the conversation between I would say a pro electrification versus a pro hydrogen conversation. So really, the lobster claw doesn't work without each claw, and so electrification needs hydrogen, and hydrogen needs electrification. There are going to be things that can't be directly electrified in the transportation sector. For example, long haul flights, long haul trucking, shipping. Those are things that can't tolerate thousands and thousands of pounds of batteries, and so that's where hydrogen really carries a strength. And then, so on the right there, some figures about what this is these numbers are the projected nationally and then also globally in the EU, but what the predicted energy mix is in each of those countries that is hydrogen. And so you can see it varies, obviously, depending on geography, and so much about hydrogen and renewables, as we've seen earlier in the presentation, comes down to geography. Do you have the sun? Do you have the wind? Do you have the landscape to make it work? And I'm sure that U.S. one has changed since then with the political changes down. So, okay, a little bit about hydrogen. For those of you who don't, we're going to go into a little bit of chemistry. Not much. I'm a mechanical engineer, so I won't kill you with this one. But it is a gas in ambient conditions. It is lighter than air. It's two hydrogen molecules. It's the energy content, and this is important, and I alluded to this on a previous slide, is that 1 kilogram of hydrogen is approximately equal to a gallon of gasoline. So yeah, there's that figure. But the important part being that hydrogen is better by weight than by volume, and so I'll get to that a little bit later. But another interesting fact, and plays into a lot of the available solutions and the promise, and what's going to work for hydrogen is that what's not going to work also is it's liquefied at minus 253 degrees Celsius, which is very cold. LNG, for example, which is widely distributed and widely refined and transported globally and growing, is liquefied at minus 160, minus 170, somewhere in there. And so to liquefy hydrogen takes plenty more energy. And then a fuel comparison from a first responders standpoint, a little bit on safety. It's colorless, it's non-toxic, it's odorless, it's super light, and it's high energy by weight. And so all of those factors chemically of that molecule play into where it works and where it doesn't. A little bit more, again, the demonstration of weight versus volume. Energy by weight, top left, really good. Energy by volume, really bad. So what's a good example of energy by weight? I already gave it: transport, long haul. And then what's a good example of energy by volume? Pipelines. So people talk about pipelines run on volume, not on mass. And so when we talk about blending, it's not exactly scientifically there's a tax you have to pay, because the energy content of your gas in your pipeline goes down when you add hydrogen. Yes, the emissions go down, but you have to consider those types of things as well. How is hydrogen made? What are the types? You'll read and hear a lot about the different colors of hydrogen. I won't go into too much detail about this one, but brown, gray, blue, pink, green. Green is renewable, pink is nuclear, blue is the traditional form, which is steam methane reforming, which is the most common form right now globally, but with carbon capture. Gray is what we're doing now today without carbon capture, so the CO2 gets emitted. And then brown is from coal. Storage, how do we store this stuff now that we know a little bit about it? So there's physical-based options. There's compressed gas, cold or cryocompressed, which is sort of a medium in between, and then liquid hydrogen. There's also material-based storage, which is where a lot of the research and promise is in hydrogen logistics and transportation. So you can use an absorbent, you can use a liquid organic hydrogen carrier. You can use interstitial or complex or complex hydrides, which are effectively a metal powder that absorbs and locks in the hydrogen depending on thermal and pressure swings. Some kind of pretty cool technology in there. But inside of that material-based category is ammonia and methanol, which are both highly talked about hydrogen carriers nowadays. Large shipping companies such as Maersk, for example, you might see them locally for me, Vancouver, but large global shipping conglomerate has committed to methanol being their fuel of the future. And so it's happening, I guess you could say. So production and use, here's a couple of good figures. Again, I'll try to go through them just at a high level to make a point on each of them, because each of them have a reason why they're there. So top left, green dial, that is the hydrogen demand by sector. So that's how much, where the hydrogen goes today. So a lot of it actually goes to refining oil, which is in a way you could think of as ironic. And then other larger sections are ammonia, methanol, steel production, and other. And so that you can imagine will change and evolve over time, but that gives you an idea of where hydrogen is used today in Canada. Globally, refining, big piece of it, synthetic chemicals, and then iron and steel on the global graph on the left. And that's actually historically, that's in the past. And so even, you know, there's been a lot of traction over the last number of years, but even without these, the larger forces that have been at play in the last 2 years, the global demand for hydrogen is increasing. And so you'll see that, I mean, it's only going to increase more rapidly. Refining and synthetic fuels is something that I'm, synthetic fuels, what I'd say is I'm particularly bullish about. I think it creates an opportunity for circularity in the energy supply chain, where we can use captured carbon and hydrogen to make fuel. Sounds kind of dreamy, in my opinion anyways, but I think it's a great way to close the loop. Alberta's hydrogen production, the figure on the bottom center, what this is, and I gotta zoom in here myself really, but is, you know, how much does Alberta's hydrogen cost? You know, what can Alberta make hydrogen for compared to the global cost range? And so the global cost range is that gray band that you see, and the yellow line is the global cost average, and then Alberta is the blue. And so you'll see that Alberta is positioned very well to be a leader in hydrogen production. And if you follow the news, you'll I'm sure you've seen plenty about the development of the Edmonton Hydrogen Hub, the funding opportunities and the research going into the Center for Excellence that's being developed up there. There's the Medicine Hat Hydrogen Hub as well that's under development. Plenty going on. These are more graphs that just say the same thing, so I think I'll skip them in the effort of time. So why is hydrogen so important? Why am I talking about it? In a word, it's a sector coupler. And the graph on the left, it is the center, because it draws and ties together this electrification and renewable energy piece with our liquid and chemical fuel demands, things like vehicles, industry, transportation. Fuel cells are going to be a big part of all of that as well. And then another figure on the right to show sort of production pathways, so to speak, how to make it and where it can be used. Oh, you guys are experts on that now. So again, moving forward. So again, why hydrogen is important. So here's another great figure of a pathway, of hydrogen pathways, all the way from the electricity generation on the left with solar and wind. You can directly electrify an electrolyzer to make hydrogen, and then use that hydrogen. You can either convert it to ammonia, methanol, or e-fuels, and direct use of hydrogen. And then, yeah, just this is a great figure for showing all the ways it can be made. We've talked about most of them, and then the use cases for it. And what this figure shows also is the size of the CO2 footprint that is involved. It actually includes life cycle emissions. So you'll even see that the electrolysis has, and even the hydro and nuclear has a carbon footprint, because it does. You have to make those materials from something, and it's usually carbon-based or emitting. This is an old figure on who's involved, but there's plenty more, and this is somewhat repetitive, but many companies and organizations are getting involved today in hydrogen and staking claims on whether they're going to develop hydrogen technology, or they're going to focus on electrification. An interesting one to follow will be that CP and CN, the rail organizations, have both taken different approaches. One of them is committing to electrification of their locomotives, and the other one is committing to hydrogen and fuel cells. So that'll be a fun one to watch. What can you do in hydrogen? How can you get involved? You can follow along with some of the provincial organizations, this is an old figure, but things have been further established beyond this. But across Canada, there are provincial and national organizations that are focusing on hydrogen. There's actually a bit of a rebranding process going on, because it's not just the Canadian Hydrogen and Fuel Cell Association. It's actually hydrogen nationally, and so each of the provincial organizations has a membership, and it's a great way to get involved, because for students and academia, there's like produce fees, stuff like that. But you can also get your company involved as well. That's kind of how I started things off with Ensol, was becoming a member, and it's been a great place to network and resource and learn about hydrogen. On the right, some spending figures. A lot of money is going to be spent on the hydrogen sector, $47 billion, so to speak, and up to 360,000 jobs in Canada by 2050. That's pretty staggering. It's going to be a big industry. So, a couple notes I want to leave on, and I got 2 more slides. Then we can open up for questions. I think I'm 2 minutes over here, but there are critics and realists out there, and I really appreciate the perspective that they provide, because in order to truly understand and take it with a grain of salt, so to speak, if for lack of a better way to say it, you got to look at both sides of the argument. You got to understand both sides. And so this particular gentleman has made 4 critical statements. Zero emissions hydrogen is an opportunity for governments to speed up the energy transition. However, the only true zero emissions hydrogen is that made from renewable electricity. Not wrong, but it's not going to be the only way we make it. Deploy green hydrogen for hard to decarbonize sectors, starting with where gray hydrogen is used today. We'll talk a little bit more about that on the next slide. Hydrogen shouldn't be used to delay deploying electrification alternatives available today, such as in heating and transport. Given how valuable green hydrogen is, blending it into the existing gas grid does not make sense due to its limited impact on emission savings. So again, a lot of these things I've sort of alluded to already, and not saying that these are all things that I truly believe in and I follow, but it's good to understand that. So I've gone and talked too much today, but this is another good a good figure. I'll only use this one, but because there's 3 others. What this shows is what the losses and efficiency losses are with each specific technology, because one of the main critics of hydrogen is that it takes an efficiency loss over electrification, which is not wrong. But this puts it into perspective and shows how much losses there are. And so how much usable energy, the percentage on the right, how much usable energy is left between generation and use. And so what you see here with shipping, for example, is that when you use oil to refine and then use it in an IC engine, you're left with 39%. So, hydrogen looks pretty bad efficiency-wise here, but what this doesn't account for is the emissions, obviously becoming a priority, right? And so technology will grow and get better over time. Here's another example: passenger vehicles. So traditional pathway, oil, refined, gasoline, and diesel, and then IC engine. And this one actually swings the other way. So what we've got as the leader in the efficiency option is renewable electricity and a combination of that and fossil, nuclear, and biomass. But this is also adding now time into the frame. So this is 2020. So let's look at the third one as a better example of today. And then our grid, an electric engine, and usable energy. But what we're saying is that we're going to get up to 63% usable. Space heating, another good one. 3 very different examples showing what the final energy content is. So you add a heat pump and apparently you break the laws of physics, but heat pumps are incredibly efficient and in my opinion, a great way to heat your home or to do space heating. It's effectively free. So that's some perspective. Here's the last one. And what this is a figure, if you haven't seen it before, it's the hydrogen ladder. What is unavoidable and what makes perfectly common sense to use nowadays according to this source. And then on the right in the middle, what you'll have no regrets using hydrogen for. Those two figures go hand in hand. So some of the things that make sense now are fertilizer, food, methanol, hydrocracking, desulfurization. We use hydrogen for that now in a lot of those areas. And so what the point being here is that the focus should be on making clean hydrogen and using it for the same things we're using it already for. That will have a greater impact in the short term. And then obviously, sort of longer term, other things will start to make sense. You can see where things sort of start to cross the line into uncompetitive and doesn't make sense, which is super interesting because there's so much in the news about it nowadays. Let's look at the very bottom: metro trains and buses, hydrogen fuel cell cars, urban delivery, to the reels, bikes and e-fuels, and power system balancing. I know companies that have committed their entire business model to those strains. So it's no one opinion is ever the only opinion and the only correct pathway. The one on the right's also fun, and I'll end with this. Is a bit more salt on hydrogen, but what this is it's decarbonization potential. What can you do? What is in our lives that actually has a mitigation potential for CO2? So the band is the range between, and if you cross that threshold into the left, you're actually making it worse. So what can we do? So like here's some fun ones. Take one less flight. That obviously has a good impact. A vegan diet is featured on here, for example, about 8 to 10 down. What else? No pets has a positive impact on global emissions. But at the very bottom, and the point that I want to leave you with is that shifting to hydrogen blindly doesn't make sense unless it's done right, because if I bake my hydrogen from my coal-fired power plant and lose all that efficiency and still emit, then it's not helping anything. There's a smart way to do it and deploy it that will achieve the goals that everyone working in the hydrogen sector really wants. And there's a way to do it economically that makes sense. And I think, frankly, I'll leave it at that. And here's some added unnecessary comedy. But for many things in life, there are some things in life where electricity is fine. For everything else, there's hydrogen. A play on the MasterCard commercials of the past. I'll hang it up there. I hope there's some questions. But if anyone wants to chime back in, there's a list of references, and thank you very much.
Fantastic. Michael, thank you so much. I thoroughly enjoyed your presentation. The last chart on the right there, it's amazing. I can't see people giving up their dogs to get to net zero, but you certainly never know.
I'm not giving mine up.
We draw the line there.
That's where I draw the line, people.
Amazing.